As AI agents take center stage in the tech ecosystem, new challenges and questions arise. One of the most important questions being, what's the best way to build AI agents? Said another way, what's the optimal architecture for AI agents? You've likely heard of LLM OS, Andrej Karpathy's brilliant architecture for a new type of computing model that is slowly becoming a reality. In this video, I want to reframe the LLM OS into a simplified OS architecture that focuses on how you can get immediate results out of your AI agents today and over the long term as the LLM ecosystem evolves. Let's break down the Agent OS. You can think of Agent OS as a micro architecture inside of LLM OS. Just like computer architectures, there'll be many different agent architectures, but what matters is the abilities they unlock for you and your work. Let's break down the Agent OS architecture in a way that makes sense and makes it easier to build agentic applications. What does this architecture look like? I've broken this down into three key sections: the LPU, IO, and RAM. Throughout this video, we're going to break down each one of these sections and why it's critical to have them in composable, reusable pieces that you can swap in and out. So there are a couple interesting pieces here I want to highlight. So in our last video, we discussed 7 prompt chains you can use to build AI agents. This is super important. This is part of the LPU, which we'll break down in a second. And our RAM, aka random access memory, we're concretely defining not just our input, but also our state, variables that your AI agent can modify throughout their life cycle. So in our IO, in and out, we of course have our tools. This allows your agent to interact with the real world, but we also have something called Spyware. You can think of this as monitoring and debugging and visualization of your agent. And then finally, we're going to talk about these really important symbols here, these right-facing triangles. If you're a functional programmer or a senior engineer, you can already tell where we're going with this architecture. But let's just give away all the ideas we're going to discuss in this video. If these topics sound interesting to you, definitely stick around. We're going to break down the Agent OS, just like you saw. There are many components there. We're going to run through them, make sense of them, and talk about how arranging your agents in the Agent OS architecture is going to help you build agents, not just for the short term, but over the long term. We're going to talk about what makes not just a good, but a great architecture. And then we're going to answer the question, is using an architecture like this, is building some type of system better than just putting together a couple prompts and a couple tools? Do we need to potentially over-engineer this to get the exact same results out of our system, out of our agents? Then we're going to push beyond AI agents and talk about what might be coming next in the industry. And then we're going to talk about the big missing piece from this architecture and really the big missing piece from the LLM ecosystem as a whole. The first thing we need to do is break down the terminology here. What is the Agent OS architecture? Let's start with the most important piece, the LPU. I like the terminology from Grok, the language processing unit. When we look at possible architectures at the agent level, it makes a lot of sense to pool all of the models, all of the prompts, all of your prompt chains, and everything inside that into a single unit. That is the language processing unit. This is the real innovation. Without the LPU, we're just designing another system with code. The LPU is what really differentiates this system with anything else that's been built in the past. We then, of course, have IO. This is your input and output, also known as function calling and tools. Your IO is what enables your AI agent to talk with the outside world. It could be the browser, it could be your file system, it could be your database. It can be anything that interfaces with the outside world. And then finally, we have RAM. So I think it's really important to establish a concrete component inside this architecture, specifically for memory, for context, for your input. There's a huge step that I haven't seen a lot of people taking with their agents yet, and that's having your agent be able to update its own state and operate on that to produce novel results. These three systems work together to create a complete AI agent. So let's break down each one of these components. The LPU consists of your model provider, your models, your prompts, and your prompt chains. Model providers are, of course, the generators of your models, OpenAI, Anthropic, Google's models, and any provider of the local models that you have running. Up a level, we have the individual models themselves, right? So now you have your GPT-3, your GPT-4, you have Claude 3, Haiku, Sonnet, you have Gemini 1 Pro, Gemini Ultra, Gemini 1.5 Pro. These are where your individual models lie. Above that, you have your concrete prompts. Every AI agent should solve one problem, and it should solve that one problem well. Ideally, you can look at your prompts and know exactly what this agent does. Notice how the prompts are on top of the models, which are on top of the model providers. At the top of the LPU, we have the prompt chains. In the last video, we talked about why this is so important. I'll link that in the description. Definitely check that video out. You can do a lot more than you think with your prompts prompts, their entire products that are waiting to be unlocked by arranging the right prompts together in the right prompt chain. It's important to differentiate prompts and prompt chains because the value you can get out of chaining together multiple prompts vastly outperforms the value you get from a single prompt. We've explored this idea on the channel. We have several videos showing this and proving this out. This is really important to mention, and this makes up the LPU. This is the key component of the agent architecture. Your model providers, your individual LLMs, your unique domain-specific prompts, and how you chain your prompts together using different prompt chaining techniques and patterns is what makes up a very powerful LPU, language processing unit. We're using the OS architecture as an analogy here for the architecture for great, powerful AI agents. So, even just looking at this one stack, maybe a question is going off in your head. It definitely has gone off in my head many times. Do you need every component to build a great agent? So do you need, prompt chains? Do you need prompts? Do you need every part of this architecture, including the IO and the RAM and its individual pieces to build a great agent? Pretty decisively, the answer to that question is absolutely not. If you can solve a problem, if you can build an AI agent that solves one problem for you really well in a single prompt with a single model on top of one provider, then just use that, right? You shouldn't over-engineer any architecture. I highly recommend you always use the bare minimum tool set you need to get your job done. Beyond all principles, that is number one. If you only need a prompt and a model provider to get your job done, to build the agent you need, just use that. So that's the short answer. The longer answer is it's important to be practicing building out these architectures and utilizing these architectures because they're going to show up in many, many shapes and forms that are going to ultimately provide you with the same end result. One of the big advantages here of having these layers is that when GPT-5 comes out, you already have support for OpenAI, so you hop into your model and you add that one layer inside your AI agent and you're done. The beauty of this architecture is that you can quickly and easily swap out any one of your models, any one of your prompts, any one of your prompt chains, and any one of your model providers and still get great results out of your AI agent. This is a huge advantage because over the long term, when you have a faster interoperable architecture, you can move a lot more quickly than someone who has to, dig in their code base and rebuild some of the pieces because they're not swappable, they're not easy to maintain, they're not easy to interchange with each other, right? So you don't need every component, but the arrangement of this specific architecture can absolutely help you over the long term. Let's move on to the next section, the RAM. Your AI agent should have the capability to operate on state. As your agents get more complex and they solve bigger problems better autonomously, they'll likely be operating on their own internal state based on the inputs that you give it. These are the items that are inserted and that work with your LPU, right? So your state and your input, they operate with your LPU, and then you might take the result of one of your prompts or your prompt chain, do some IO, update your state, and then based on that update to your state, run a different prompt or a different set of prompt chains. You can see how that could be useful over time. If you're enjoying this video so far and the LPU and the RAM are making sense, definitely hit the like, hit the sub. In future videos, we're going to be building out real examples of how you can use this architecture against real use cases. We'll build concrete Python and TypeScript classes that utilize this very architecture and chain together the ideas we're discussing in this video. Lastly, we have IO. You're likely very familiar with tools already. This is how your LLM, this is how your prompt, this is how your agent interacts with existing functionality. This is how we make web requests. This is how we interact with databases, files, so on and so forth. We then have this additional layer here that I think is really important to uniquely specify in the IO layer, which is spyware. I'll link the videos where we discussed spyware in the past, but I don't see enough people talking about how they're monitoring their AI agents. Monitoring the state, monitoring the prompt, monitoring your inputs and outputs. I think when you're building out your AI agents, you want to have some system, even if it's just something as simple as logging to a file via one of your tools. I think it's important to make the concrete differentiation here that your spyware enables you to inspect logging and do debugging on your individual agent, right? Once you get complex enough agents, they're doing a lot of work, they're operating on a lot of state. Something's going to go wrong at some point. You're going to want to dig into your agent and see what exactly happened so you can tweak your IO, your RAM, or your LPU to make improvements to your AI agent. If you can't monitor it, if you can't measure it, how will you improve your system? So These three components make up what is the agent OS, the agent OS architecture, LPU, IO, RAM. You've likely already used these in different versions. Maybe you call them something else. A lot of people like to call state and input, the RAM section, just the context window. I completely understand. I think it's important to identify it as a separate unit because really you can have RAM sitting on the side, you have files, you have databases, and then when your LPU needs information or when it wants to update information to help it solve a problem, it runs a prompt chain that interacts with the IO that can update your RAM, so on and so forth, right? I think that most agent architectures have some form of these three units: your IO devices, aka tools, your LPU, aka your prompts, and your RAM, aka your state, your variables, your context that live inside your agent. So this is great. We have a solid architecture. Now it's really important to ask the question, after you build an architecture, after you design some system, how do you know your architecture is good? How do you know that what you've done is an improvement at all, right? How do we know that this is better than just putting two prompts together and giving your second prompt a tool and calling it a day? If we look at Andrew's LLM OS video here, he has this really great list of what he thinks LLMs will be able to do in a few years. It's crazy how many of these things they can already do. So let's think step by step and go through this list and see if our agent architecture can perform these tasks. It can read and generate text. Of course, the LPU has that covered. It has more knowledge than any single human about all subjects. I think the LPU in combination with a web browsing tool has this capability. How easy and accessible is it to accomplish that goal is definitely up for debate. It can browse the internet. We'll leave that up to the IO. It can use existing software infrastructure, calculator, Python, mouse, keyboard. This is up to the responsibility of the IO and the tools available in combination with some really great prompts. It can see and generate images and video. So if we have the right model in our LPU and the right IO, we can definitely read in files. You're definitely already aware of models that can perform those tasks. We're still waiting on a great video model. It can hear and speak and generate music. We're there with the music. Hear and speak is still a work in progress. There are TTS, text-to-speech modules that are getting built out, tools like DeepGram and others. I think we still need to see the costs come down for TTS, but through this agent architecture, when that system rolls out, we'll be able to handle that via IO and LPU. It can think for a long time using System 2 thinking. The LPU prompt chains in combination with our RAM can definitely accomplish that goal. You can imagine we have a prompt chain that includes several, think step by step, review your work, that then outputs and reviews several plans that can be then written to RAM and then reloaded into additional prompts. We can think of that as a great way to build out System 2 thinking. It can self-improve in domains that offer a reward function. This is a really important topic we're going to discuss at the end. I think currently this agent OS does not have the ability to self-improve. We'll talk about that in a second. It can be customized and fine-tuned for specific tasks. Many versions exist in app stores. So I think customization and fine-tuning definitely happens at the model provider and the model level. The agent OS can quickly swap in and out these different models to perform the task at varying degrees based on their model. And as many of you know, the rat race for building out and deploying AI agents as apps through some type of, GPT-like store is definitely underway right now. OpenAI has taken a first shot at that with the GPT store. And then finally, it can communicate with other LLMs. This is a really important idea, and we tapped on it in the beginning of the video. Let's talk about what these right-facing triangles mean, because it can communicate with LLMs is a really powerful idea, really powerful notion that really speaks to where AI agents are going and what the next step is after you have clean AI agent architecture that you can reuse and quickly build and improve on. So at the start of the video, we highlighted these 2 points. Let's talk about composability. These 2 icons might be the most critical aspect of this AI agent architecture. We have the LPU, we have the RAM, we have the IO, and then we have inputs and outputs. In previous videos, we talked about treating everything like a function. You can think of your agent OS as an individual function, a black box that takes inputs and produce outputs. This ability allows us to compose our agents together. I've talked about this many times. I'm going to keep talking about it because it's a critical design technique. Composability lets you take your smaller pieces and put them together to build something greater. You can see here, these arrows represent our inputs and our outputs. And of course, if you have a clean typed function or a clean typed system that has a unit of work, this individual agent, and it produces output in the same shape as the input to another system, aka our second agent, you can compose these agents together just like you can compose functions functions together when you're writing code, just like you can compose anything. Composability, reusability, and interoperability of your agents is something that will take your agent architecture to the next level. You can expand on this to chain together 1 to n agents, build out entire agentic workflows, which is the next level of abstraction beyond the AI agent. At first, we have LLMs, then we have prompts, then we have prompt chain, then we have AI agents, and the next step after that is our agentic workflows. Agent 1 feeds into agent 2, feeds into agent n. That's why it's so important to build these modular, reusable systems that operate well on their own, but also can be used as building blocks that can be stacked up next to another agentic piece of software. You put enough of these together and you get a living system creating value on your behalf while you sleep. That's really where we're heading on this channel. It's about building these systems. It's about understanding the lower level units, composing them up, building them up, making them reusable so that we don't have to keep rebuilding the exact same system due to sloppy architecture. This idea really highlights this question again, right? Do you need every component to build a great agent? No, you don't. You don't need this architecture. You don't need the agent OS architecture at all, right? If you can solve the problem with a couple prompts, do it. But what you will miss by not using an architecture like this is the reusability and the composability of the system as a whole, right? Always pull back the curtain of your system and ask, this is great, it solves the problem, but what happens next? There's always another level for your architecture. There's always another level for your system, for your product, for your tools, and for you. So as you're building it out, as you're designing your systems, always have in mind, this is awesome. If I accomplish everything I want to here, right? If I build a great agent, what happens next? What's the next step? Composability of your AI agents is the next step toward building true agentic software. If you only take away one thing from this video, it's this idea. You want to be building AI agents that solve a problem for you and that solve it well. After you do that, you want to push it a little further and ask, how could I use this agent as a piece in a larger system to drive even greater results? So there's one more thing to discuss with this agent architecture. What's missing from agent OS? No architecture is perfect. There's always a flaw. There's always a trade-off. What's missing from this system? Andrej Kaparthy talked about this idea here that we completely missed, that we completely skipped over. It can self-improve. This is what is missing from not just this architecture, but from many agentic systems, many applications using LLMs. No one has cracked the case on self-improvement. How can your agent self-improve? This simple diagram summarizes that next level, that next step. You have some loop that runs, some system that runs, and then on execution, it learns, it improves, and it can accomplish that exact same goal in less time, with less resources, operating faster, operating more concisely. It can drive the results you're looking for in an improved way. What happens when you run the system again? The exact same thing. It has a improvement reward function that runs that allows your system to self-improve. This is a major missing piece from the agent OS architecture. And again, I think from the LLM ecosystem as a whole. After that finishes, you can recursively loop this at a higher level and functionally have your agent self-improve to infinity or until your OpenAI credits run out, right? So this is a big missing piece. In combination with composing AI agents, this will likely come around the same time. I'm still playing with this idea. I'm still working through what this might look like. I think on the low level, on the ground level, outside of the model, self-improvement involves running your prompt chain, and then updating your RAM, updating your state to say, this result was not that good, or this result was great. Let's do more of that. And then that result feeds back into your prompt chain and then reruns throughout your IO and your RAM, right? That then again updates the state that feeds right back into your prompt chain, right? So I think self-improvement on an agent level looks something like that, but I'm still working through this idea. I'm still testing. I'm still experimenting with a lot of that. So I have nothing concrete there, but I want to call this idea out for you because in combination with composability, this is how we go beyond the AI agent. We make it self-improve. So that's Agent OS. There are a lot of ideas there. I'm going to try to clip this video down for you, get it into a compact version that makes sense. I want to reiterate this idea one more time because it's really evolving and it's taking different shapes and forms. The prompt is the new fundamental unit of programming. And that means the prompt is the new fundamental unit of knowledge work. If you can master the prompt and all of its derivatives, which of course is the prompt chain and now the AI agent, you'll be able to build, create, and manipulate data and information like no one has been able to in the past. You'll be faster, you'll be more accurate, you'll be building products at an insane rate. And really, I think AI agents is the new oil, it's the new gold, it's the new currency, whatever you want to call it. And all of its lower level components are equally as critical. In future videos, we're going to utilize this architecture. We're going to build out concrete examples and solve real problems using the Agent OS architecture. As I mentioned previously, I am actively working on what I believe will be one of the most important agentic applications any one of us can build and use. I'm working on my personal AI assistant. I'll be sharing videos on that in the future, and we'll be digging into more mission critical tools like AI coding assistants and other related tools that help us build out agentic software so we can evolve our engineering, evolve our role as engineers, so we can move ourselves up the stack to continue doing what great engineers do. We control and we manipulate data faster and better than anyone else. At the core of engineering, that's what it's all about. Thanks so much for watching. If you got value out of this, definitely hit the like, hit the sub, and I'll see you in the next one.